All right. On the sheet, you're going to write quiz preview, muscle quiz preview. I'm going to give you some questions. You're going to answer to the best of your ability what you know from the information I've given you over the last week and even the summary you got from yesterday. All right. So number one, define concentric. Define concentric. Just what is the word? A concentric muscle action. Define it in your words. Concentric. What does it mean? Number two, define eccentric. So again, on your sheet of paper, separate sheet of paper, muscle review, muscle quiz preview. I'm going to give you these questions. Just write the answers to the best of your ability. So concentric, and then what is eccentric? Number three, define isometric. If I were to do an isometric exercise, if I were to do an isometric exercise, what would that look like? Just define it in your own words. Number four, agonist. An agonistic muscle. What does it mean to you? If I were to tell you the hamstring is the agonist, what does that mean to you? Oh, number five coming up, okay, is antagonist. What does antagonist mean? How is it? How would you define antagonist? All right. Get your notes out. That's just 5, right? Gonna keep that for now. Get your notes out from yesterday. I'm gonna give you the next set of information with regards to the muscle system. It wasn't too bad, right? 5 questions. That's it. Got one? Okay. Keep that sheet. We're going to build on that over the next few days. And then we'll review. And if you got answers wrong, that's okay. We'll make sure that you get them right. What's up? Yes, notes from yesterday where you wrote a bunch of stuff down, right? That I gave you. All right. Here's the next step. All right. So we've covered quite a bit of muscle agonist, antagonist. Let me ask. Nothing to write down. If I were to stand on my tippy toes, right, and I'm walking on my tips of my toes, what movement is my foot at the ankle at? What action is that? You should know. That's plantar flexion. If I'm walking on my heels, what would that be? Dorsiflexion. If I'm walking, which typically wouldn't occur, but if I'm walking on the outsides of my foot or my feet are rolled inward and my toes are inward, what is that motion? Inversion. And then opposite would be eversion. Okay. Front of the muscles on the front of the thigh. What is that muscle group called? Muscles on the front of the thigh. Quadricep, muscles on the back of the thigh. Hamstring. What muscles flex the hip? Quadricep. What muscle extends the knee? Oh, quadricep. Quadricep, right? Remember the karate kick, right? Karate. What if I extend my hip? What muscle is doing that? Hamstring. What if I flex my knee? Hamstring. What muscle plantar flexes the foot? Calf. Yeah, but what's the muscle called? It's gastrocnemius. Okay, good. What muscle is antagonistic to the gastrocnemius? Good. Excellent. So if I dorsiflex my foot, tibialis anterior is doing the work. That's a concentric muscle. What muscle's on stretch? Gastrocnemius. Right? So they're antagonistic muscles there. What if I flex my arm, my elbows? What muscle's agonist? Muscles doing the work. Bicep. So you say, when I ask you agonistic muscle, what is the muscle that is agonist? How would you define that? You could say the muscle that is doing the work. Also, it can be defined as the prime mover. Prime mover. The muscle is doing the work, the prime mover. So if I flex my elbows and the biceps are doing the work, what muscles on stretch? Tricep. Correct. Correct. So, there's some more terms for you. Closed chain movement. So make sure we're writing this down. Closed chain movement. So here's the sentence I'd like you to write down. Right above here. I'll read it out. It's a little, see if I can blow this up. I'll have to figure a way to see if I can expand this. Closed chain, I think it's maybe here actually. Maybe it's not there. Closed chain movement. Primary characteristic. You don't have to write primary characteristics. Closed chain movement equals an exercise where the person's hands or feet, an exercise where you can just write what I'm stating. An exercise where the person's hands or feet are fixed and remain in contact with a stationary surface. An exercise where the person's hands or feet remain in contact with a stationary surface. Closed chain. Basically, the body and the surface meet and close the gap. The body and the surface meet and close the gap. So there's no opening between that body and the surface. It's closed. It's closed contact, basically. It's closed contact. So, a squat, examples, put examples, a squat. Examples of exercises. Squat. What else? What else could you think of that would be a closed chain exercise? What? What'd you say? Deadlift. Okay, good. Deadlift. Now, here's one thing about that. Let's go back, and I'm not gonna let me go back to where I said good. Good. That's correct. What's moving in the deadlift? There's something moving in the deadlift. So if we're doing a deadlift, the squat is here and the feet are closed, correct? The deadlift is here and we're standing up, right? Would there be closed chain? I'm trying to trick you a little bit. Would it be closed chain? Okay, good. It still would be closed chain. All right? Still would be closed chain. It's good one though. What else? What else would be a closed chain exercise? What? Push-ups. Push-ups? A push press, it would be open chain. What else? Bicep curl, open chain. What else? A few more. What? Plank, closed chain, yes. Sit-ups, open chain. We'll talk about that in a second. Closed chain, what else? Lunge, a lunge would be closed chain. Let's look up deadlift. I'm actually a little curious if deadlift is deadlift an open chain, or I think it's open, but I think it might be open. Let's look it up, Vince. Okay, yeah, you're right. Deadlift closed chain. So I was a little bit wondering. Uh, yeah, closed chain deadlift. Okay, so let's go through open chain now. So these are closed chain. How about pull up? What do you think about a pull up or a chin up? Closed, right? Yeah, it's on a fixed surface or fixed point of contact. Let's do open chain now. Open chain movements. Here's the exercise. Hands and feet are not fixed and they are free to move in space. Hands and feet are not fixed and they are free to move in space. So running is it's more the cardiovascular stuff. We're not really pertaining to closed or open chain. It's more the strength aspect of it. Okay, so hands and feet are not fixed and they're free to move in space. So let me give you one. Lat pull down is an example. What else? Bicep curl, bench press. We're moving bicep curl, lat pull down, leg curl, leg extension. These are all open chain. What other examples can you think of that would be open chain? Lat raises, good. I know you're probably just stretching, but or were you actually really doing it? Yeah, lat raises. Yep, that's open chain. Lateral raise, tricep extension, dips. Sorry, I meant this. Tricep extension, dips actually would be what? Closed chain, because you're actually fixed. Okay, if you're doing dips, that's closed chain. So there's your other pictures. Let's go over the definition of tendon. Okay, so a tendon, you can write this down, is a fibrous connective tissue that connects what? Muscle to bone. So fibrous connective tissue that connects muscle to bone. It says right here. A fibrous connective tissue that connects muscle to bone. That is what a tendon is. Again, fibrous connective tissue that connects muscle to bone. All right, let's retake a quiz. How's that? What is the most accurate description of motor control? Is it the motor response to internal and external environmental stimuli? Is it the integration of motor control processes through practice? The cumulative changes in motor behavior over time throughout the lifespan? Or the ability to initiate and correct purposeful control movements? Remember, motor is what? Movement. Sensory is what? You remember? What? To feel or sensation. Sensory, sensation, motor, movement. So the most accurate description of motor control, what do you think it would be? The ability to initiate, let's try it. Good job. Ability to initiate and control purposeful controlled movements. Good. Next. During a squat, the lowering phase would be described as what type of muscle action? Isokinetic. Here's what write this down. Here's what isokinetic means. Isokinetic is movement that is controlled throughout the motion with an external stimuli. A motion that is controlled with throughout the a movement that's controlled throughout the motion. I think I said something similar to that. With an external stimuli or stimulus. Say stimuli. So basically what that means is this: if I have something on my elbow and I add numbers to it, it's a machine, it moves it for me. So if I injure my elbow and I need a machine to help me with my range of motion, I can go to a clinic, they put it on me, and it actually does it for me. So that's considered isokinetic. It's done for the person, done for the joint. So let's go. So we know it's not isokinetic. During a squat, the lowering phase would be described as what type? Is it isometric? Well, is it okay? Is it isometric? Why not? Because you're moving. That's correct. Isometric is what? Still, you're stationary, right? Would be, if I had dumbbells in my hands, this would be, and I'm holding it for 10 seconds, this would be an isometric exercise. So it's either going to be eccentric or concentric. Garrett says eccentric. Let's try it. Good job. Why is it eccentric? Okay, so concentric is shortening, right? Eccentric, you're right. Eccentric is still contracting, but it's a lengthening. It's more of a lengthening. It's still It's not working. It's working, but it's not working as hard. It's more of a lengthening contraction. Still an eccentric contract. I want to make sure I'm clear. Concentric and eccentric are still both contractions. They're just different types. The concentric is a shortening. So it's not shortening, right? We're going into a de-lowering phase. We're in an eccentric contraction because of the lengthening aspect, really, of most of the muscles, especially the quadricep. It's good. Eccentric, good stuff. Which of the following examples describes a muscle that is functioning as an antagonist? Okay, so let me go over some of these muscles, all right? Because we haven't covered these a lot. The infraspinatus is being active during shoulder external rotation. So the infraspinatus is an active external rotator. Okay, let me give you that. The infraspinatus is an active external rotator. So if I were to externally rotate my arms, infraspinatus is working. So in a throw baseball, the windup, the infraspinatus is working on that windup, is helping that windup. So the question would be, which of the following muscle describes a muscle that is functioning as an antagonist? The infraspinatus being active during external rotation. Would that be an example of the antagonist? Why not? It's helping, not working against it. The infraspinatus is what? It's actually the what? The prime mover, right? It's the agonist. So it would not be that. You got that? Okay, the transverse abdominis being active during hip extension. The biceps brachii being active during elbow extension, and the serratus anterior being active during shoulder flexion. So the serratus anterior actually does some shoulder flexion. It helps with it. It's actually a synergist. So write this down. Synergist. Synergist assists the agonist. A synergist assists the agonist. So let me ask you something. In shoulder flexion, what muscle is a prime mover for shoulder flexion? We kind of talked about it yesterday. What's up? Yes, the anterior delt, big time shoulder flexion movement. Also the bicep. So would the serratus anterior be an antagonist to that if it helps it? It wouldn't, right? Because it's a synergist. So we have two more left. So hip extension is this. And then you have biceps brachii being active during elbow extension. So here's biceps brachii does this, right? So this is elbow extension. What does that? What does elbow extension? What muscle? Tricep does elbow extension. So would the biceps brachii be the antagonist to that? What do you think? Garrett? I hear some yes nods, yes. It would be. Let's try it. What do you think? Biceps brachii is the antagonist, right? To triceps, to elbow extension. Well, let's move on. Okay, here's another one. Stored energy from efficiently functioning stretch shortening cycle is released during which muscle action? We haven't really gone over that either. Okay, let's go over this one. It's very important. Okay, shoulder depression. So write this down. Shoulder depression, or sorry, scapular depression. Write this down. Scapular depression scapular, and then write a few lines, like give yourself like 4 lines, and then write scapular retraction. And then write 4 lines, and then write scapular elevation, and then 4 lines, and then scapular protraction. Scapular protraction. So because you know what the scapulas look like on the back, I would like you to draw two scapulas, like a right and left scapula, kind of like they're faced as if you're looking at them. You don't have to draw ribs, just draw two scapulas like this. Draw them under each one. Scapular depressions, scapular protraction, scapular elevation, scapular protraction and retraction. Draw them. So draw the scapula as if they are, as if you are drawing it on a body, but you don't have to draw the ribs. Just draw two scapula like you're looking at them for the back. And then when you get that done, when you wrote or scapular depression, what do you think scapular depression would look like? Draw an arrow. Draw an arrow comparing what they would both look like. Say you did scapular depression, both of them at the same time. What would that look like? What direction would the scapula be going? So draw an arrow facing that direction. Do scapular elevation. What would scapular elevation look like if the scapulas were to elevate? Naima, hell of a game yesterday. If I didn't tell you already. Did I tell you already? I think I did, but do it again, hell of a game. So there's two left. Scapular retraction. Scapula are going in toward each other. So make the arrows go like as if they're going to, we call them kissing, like as if they're going to kiss or as if they're going to touch. And then scapular protraction would be the opposite, as if the scapula would be moving away from each other. So what's the answer? What movement term is used to describe the concept of adducting the shoulder blades so that they become closer together? Retraction. Okay, let's try this one. Should be able to get this. Pronation of the foot. It's a different term. We haven't used this before with foot, more for the forearm. Pronation of the foot describes what multiplanar movements? Let's put our heads together on this one. Eversion, dorsiflexion, and ankle abduction. Eversion, dorsiflexion, and ankle adduction. Eversion, plantar flexion, and ankle abduction. Or inversion, dorsiflexion, and ankle adduction. Pronation of the foot. So what's pronation mean? Do you all remember what pronation is? And supination? What's prone? Laying on your stomach, face down. Correct. What's supine? Laying on your back, face up. So if I'm talking about pronation of my arms and supination, what would be pronation of my arms? Palms down. Supination would be what? Palms up. So let's go to the foot. Pronation of the foot describes what multiplanar movements? Think of your feet now. What would the movement be? Would it be eversion or inversion? To start. Well, it would be inversion or eversion? What do you think? Eversion? I'm thinking eversion. So let's rule out inversion. There's 3 left. Inversion dorsiflexion or inversion plantar flexion and ankle abduction. So we're going to go dorsiflexion. Okay, so now we're going to cut it down to 2. Ankle eversion dorsiflexion, ankle adduction or abduction. What do you think? You want to go with abduction? Ankle eversion dorsiflexion, ankle abduction or adduction? Let's just go with abduction because this is a tough question. Let's see. Pronation foot does not include ankle adduction, so it'd be the opposite. All right, so we haven't come about that yet. All right. Back. Let me just show you the scapula real quick because there's a picture of it on here. Okay, here we go. So here's your scapular motion. There's your retraction, your protraction, your elevation, and your depression. So just so you see that picture. And then here's your pronation of the foot, which is, we don't really talk too much about pronation, supination. Here's your motions real quick as a review. You have your extension, your flexion, flexion extension. We talked about that already. Flexion extension of the spine as well. All right, so I'm going to give you a quick little review sheet. You can do this, and this will be, you can work on this together. It's agonist pairs and muscle contractions, front and back. I'll give that to you. And then when you're done, you can turn it into Google Classroom as an assignment, and then you'll be finished for the day.